Hi everyone. My name is Claudia, as everyone has heard already. I am currently working with YLD as a front-end developer, doing React. I am going to talk a little bit about using Apollo with GraphQL, and also about the reasoning that led the team I was working with to choose Apollo. Let's get started. There's emoji and dog pics, so I hope it's fun. So when I joined my current team, we were briefed on a new app, and it would be quite a complex app that would bring data from several microservices, and it would need to connect them all. It was a single-page app built with React. We had designs, but we needed to connect to a REST API that was still being written. And we weren't sure how the API would be structured. So in the beginning, we would need to build this app in a way that we could plug in the API later, but still build the interface. So we thought about several approaches for this, and the first approach that we picked was Redux Saga, because we wanted to use Redux and we needed to do it in an asynchronous way. So our sagas would make calls to a mock API, and then later we would remove the mock API and plug in the real REST API services. The reason why we picked sagas at that moment was because they were fairly popular, and we wanted to try them out as well. So they managed the synchronous state really well. We could know when the API requests were being loaded, when they had finished, when there were errors, and we could share the data across all parts of the application, which was really nice. There was a main drawback for us. It was too complex to set up. It was a bit complex to maintain, at least the way we set it up. We also assumed that these APIs would be tailored to the application. So the reality was that these APIs were being built for our front end, they were being built for an iOS app, and they were being built for an Android app. So they were not ideal for our app only. They were built across several microservices that we needed to connect to separately. But I will get to there later. So when finally the APIs were getting ready, we started talking to the API devs. And this is not the actual thing that we needed to fetch, but it was quite similar. So for one of the pages, we needed to fetch a list of customers that contains the name of the customer, the email of the customer, the list of their favorite books, and the last book that they had read. It was something like this. The answer that we got was, okay, so you need to fetch this list of customers from this microservice. It will contain name and email, and then you need to fetch the list of books for each customer separately, and then the last book read also separately. And then we're like, okay, this is just a client-side app. This is going to be searched from S3. There will be one HTTP request for that list, and then for each customer, we may fetch 20 customers at a time, and we will make 2 API requests for each customer. This is not going to work. This may fail. There's too many failing points, too many failure points. So we asked, can we find a solution where we can get only one list? After, there were lots of considerations in here, of course. There was time constraints, lots of things, but in the end, the answer that we got was these services don't have access to each other databases. They're microservices. They're living separately in several, they're deployed separately. They don't know about each other for now, and we can't realistically give you a way to retrieve a single list with these things within the time frame that we have. So you'll need to make those 2 extra requests per customer. So this is when we were like, yeah, what do we do? We were not even used to write backend code, right? We're just front-end developers. So we, for a week, we made lists of data that we needed. We tried to convince still the API developers to give us proper lists, to give us just one list. They couldn't, of course, because they just couldn't. Sometimes that's how it happens. So I was really upset at this moment, and I went for lunch with friends. And one of them is a front-end developer, and he happens to be there. I complained about this problem, and he said, "Okay, I think that GraphQL may be able to solve this." At this point, I guess even none of us knew a lot about GraphQL. So I remember asking him, "But have you worked with it? Do you know if this is front-end only, if it needs a backend?" And he said, "Oh no, I think it's front-end only." So you know, it is not front-end only. There's a server, yeah, this is how much we knew about it. So I went back to work, and I read a little bit about it, and I talked to one of my colleagues, and I told him, "Okay, I heard that GraphQL may be able to solve this problem. Have you ever worked with it?" And he hadn't, but he read about it, and he was really excited about it, and he decided to investigate. I didn't think about this for a long time. For a week, I just continued using sagas. I was just, okay, let's just fetch all the things in the front end, whatever. But after 1 week, he comes up with this. He found Apollo. Apollo is a client and server implementation that lets you work with GraphQL really easily. I will show you in a bit how that works. The reason why we decided to choose it was that first, it works with several types of front ends. It works with it works with Angular, plain JavaScript. You can plug it into any framework. It works with React, which was what we were using. Works with iOS and Android. So this would be a really good idea because the company was also building iOS and Android apps. It's really well documented, and for other people, for everyone that we talked to, it seemed easier to use than Relay. And the developer tools are really good. Those were some of the reasons why we decided to pick it. And it has been working really well for us so far. Yeah, so after talking about it, we decided, okay, let's pick it, let's use it. And it really enabled us to deliver a really consistent product, which was, it enabled us to deliver a product within the deadline without too much effort, and we managed to write our own server. Yep, that's it. Now we'll have a quick demo. I built this app just as a test, so you can see some of the features of GraphQL and Apollo. And this is an app that fetches dog photos from Flickr, from Twitter, then joins the lists. So it's an example of how to fetch data from several places. And then you can rate the dogs via Firebase. Yeah. And it all connects. The front end doesn't know about Twitter, Flickr, or Firebase. It's all the backend server that knows about it. The front end just communicates via GraphQL with something called queries, mutations, and subscriptions, which I will show you in a bit. But now, if you guys want to, please open this page in your phone. You can open any of them. One of the links is shorter, but I don't know which one is easier to open. Yeah, please just quickly raise your hand once you're done.
Why don't you cats?
Sorry?
Is there a cats version?
Sorry. It's on GitHub though, so you can go there and change the tags.
Is there any Wi-Fi?
It's guess that guess Password is lowercase guest wireless.
Okay.
Guess nest, right?
Yeah. Password lowercase guest wireless.
Yeah.
I think a QR code would probably help.
Yeah, that would have been.
Super lazy.
Yeah, that would have been a good idea. It's quite a big TV.
That's 10 seconds of typing easy. Just got back at the time.
Yeah, sorry about that. Okay.
Don't thank me. Thank the Windows people.
What was the password again?
Wireless. There's no wireless.
Yeah, guest wireless.
Yes, wireless.
Everyone got that?
Is
Guest net, password is guest wireless, all one word. Yeah?
I can.
All lowercase.
No. Yeah. Yeah. How many people have it open already? Okay, this is perfect. Okay. So yeah, I guess you guys can just start rating, and if you look at the page, if everyone could rate the first three, then you'll see the ratings updating live.
First three, I'm already on 10.
Yeah, you see, like the third one is updating. Yeah, 6. Who is rating that dog as what? Who is doing this? That's a really cute dog. Okay, so yeah, you can continue playing with it. But what this uses something called a subscription that is really easy to create with Apollo. Your client simply asks for updated data, and it just gets the new data without knowing where it comes from. It just knows that it comes from the server. I'll show you in a bit, and it communicates via WebSockets, and the setup is really easy. Okay. Yeah, it's here, so you can continue looking at dogs after the talk. Okay, so how does this work? So the front end, this is called, it's written GraphQL, but it's pronounced graphical. I don't know if you can see this. Yeah. It's pronounced graphical. So for people who have worked with GraphQL, you're familiar with this tool. For people who aren't, you can run all your queries, mutations, and subscriptions, which is how you communicate with the server via GraphQL. You can run them here while you're developing, so it's really helpful. So for example, this is how the front end gets the photos. This is all the front end knows. It knows it wants a list of photos. With a hash, a type, a URL, a link to the original, and the rating. So even though they come from the rating and these 4 come from different sources, the front end doesn't know about it. The front end just receives them as it wants. So if I click, it will fetch the list. You can see here the list of operations that you can perform in your GraphQL server. So you have a query, which is this thing that I've done here. And if you click through it, you can see that you can get a list of photos, and the photos contain these fields. So this comes really cheap. You just declare the types, and it just connects automatically, basically. So the other thing, apart from queries just fetch. The other thing is mutations. So for example, if I want to vote in a doc from here, I can just add the vote. And this means that when I run this mutation, I will add a vote with this I will vote in this photo, I will give it a 10, and once the mutation succeeds, I will receive the hash and the rating of the new photo. So this means that once the front end gets this, it can just find this photo in the list and update the rating. So we can do that, and it updated the photo. The other piece, which is the one that you saw when it was updating the doc photos. It's a subscription. It works more or less the same way. You just say, I'm subscribing to rating changes. And when a rating changes, I get the hash of that photo and the new rating. So you can see that there's nothing here yet. So if I come here, I'm going to vote again in this photo.
That's cheating.
I just really like this dog. And you can see that it's here, rating changed. And this is what the front end will receive in this shape. Okay. Something else that may be worth noting. So when we write our code to resolve these queries, if we write this in the correct way, if I remove rating, if you remember, goes to Firebase and fetches the rating from Firebase. So if I run the query now, Firebase won't even be called. So it makes it faster. If you just need this little piece of data, then you don't need to fetch everything, and you don't need to call all the APIs. So it's really helpful like that. What else? The developer tools, which I talked to you about. They contain GraphQL, as I was showing, but there's something helpful. You can load the data from cache. Apollo just creates a cache in your browser, so whenever you return to a page that you've been to before, it already has the data there, so you don't need to fetch it again unless there's some specific reason. So we can emulate this behavior with the Apollo dev tools. I just called the query, and you can see it was really fast. Just loaded it instantaneously from cache, from the store. And the store is here. For example, if I wanted to, I can also search it. If I wanted to see which photos are from Twitter, yeah, you can see it there. It highlights Twitter photos or Flickr photos, because there is a property here called Flickr. So it's really easy to find if you have a bug with caused by some data, you can find it really easily with this. And then you can see which queries you performed and which mutations you performed. Yeah. So yeah, it's simple, but it's really nice to work with. I think I'll show you a little bit of code. I'll try to be fast, because this is all in tutorials online. So yeah, I think I need to press here. Okay, so the first thing that you do when you create an Apollo server is you define a schema. And this is how you define it. For example, this type query. It's how you define that query that we just did that you just ran for the photos. So if you look at this, that type is exactly this. What we're saying here is when we query for photos, we get a list of photos, which is this. So you can interconnect the types really easily. Same thing for mutations, and this is just a string. Yeah, you can define the types that you need in your variables. A really nice thing about this is that once you connect your client to your front end, this schema is sent to the front end, and then the front end knows what data it can send, and it will throw an error immediately if you sent a parameter with the wrong type. Saves a lot of time. And yeah, subscriptions is the same thing. Yeah. And then you plug it in together with these resolvers, which I will show you later. The resolvers are just functions that actually fetch the data for your schema. So you run a query, you ask for the data in this schema, and then the resolvers are triggered. And they actually call the APIs and get the data. So in this case, you can see here I have this query. This is the shape of a resolver. You have query photos. This is the same shape as the type. Here, type query. Mutation is the same thing. We defined type mutation just there. Type mutation add vote. Yeah. And then here it's the same thing. Mutation add vote. We call an async function, a promise, whatever we need. And that add vote is calling Firebase on the background. And then we return the hash, which is what we asked for in the mutation result. Oops, sorry. It's what we asked for in here. We asked for a hash and a rating. The rating will resolve differently. We'll resolve separately because we may not want it. And I'll show you in a bit. And then we publish an event for the subscription. So if someone is using the app, they will see the updated rating. Subscription is a little bit more complicated. I'm not going to go through this. But it's just defined the same way. Subscription, and when a rating, you want to subscribe to rating changes, and then you run your code. Yeah, so you can see queries, mutations, subscriptions. So this is how we fetch the rating. So the type photo contains a rating property. So when we asked, we can create resolvers just for types, not only for queries and for mutations. So when we ask for a photo that contains a rating, and only if we ask for the rating of that photo, it will call Firebase and get the photo. Setting up the server is really easy. You can use Express, Happy, whatever you want. And setting up subscription server is also really easy. This is going to change in the future because Apollo is updating this, but this is how you do it at the moment. Testing is also, you can do kind of end-to-end tests. You can call GraphQL with this query and check that your data comes up in the expected way. The front end, it's also fairly easy. You configure a client and you wrap it up in a provider. I don't know how many of you have used React, but it's similar to Redux provider. Yeah, it's a common pattern. And then you use it with higher order components. And then to fetch the photo, you just run a query. And you get an object more or less with this shape in your component. You know if it's loading, you get a function to subscribe, and you get a list of photos. And then just use it. You can check if this is how you check if it's loading or not. And subscription is the same thing. Basically, you can see that the client just communicates via these strings and just asks for the data that it needs. And then once we get something new, we update the list in kind of an immutable way, but you can do this in any way, actually. And adding votes, I'm just repeating, it's basically the same. This one is slightly different. You can receive arguments from your component when you call this mutation. And you wrap your components with a higher order component to which you send that mutation string. And you can name the function. Oh, sorry. We're almost finished. And yeah, then calling the mutation is also really easy. You just call a function with the variables that you need. And that's it. This returns denable, so you can do things with it. You can wait until the mutation finishes and change the state. And then you send the variables that you want. This is what you've seen here. I'm sending a photo hash and value. And you can see it here, photo hash and value. And yeah, this is it. Any questions? Oh, okay. I think you raised your hand first. Yeah.
1 second. I'll get your mic.
Thank you.
Okay.
Before we do that, this is Claudia's first talk on meetup. Can we all just give her a massive round of applause?
today. Thank you for a really good talk. My question is, maybe others have this question as well. I have actually developed something with GraphQL before a GraphQL server, but not necessarily with Apollo, the Apollo framework. Question now is, I see the power of the clients. You've got clients for iOS, for Android. Is there any way of actually being able to utilize, or have you, experienced this, or has anyone actually experienced this, whereby they could use a schema or already existing schema in a kind of vanilla GraphQL schema style, put that into Apollo and use the Apollo clients?
You probably can. I think it's interchangeable because Apollo in the background uses just the GraphQL package. So I think probably we'd need to do a couple of changes because of the syntax, but I think it's definitely interchangeable. I'm not sure, but I think it is. Yeah. I think there was yeah, next.
Hi, thanks for the talk. I just wanted a quick question on where's the data stored? So when you add the votes, is that stored in Apollo?
When we add the votes, this app works kind of as a proxy, so the votes are stored in Firebase, but everything in the app is stored in Apollo as well. It's cached in a Redux store. Yeah. Yeah. Sorry, guys.
What about how do you see lazy loading versus the GraphQL way? So would you rather wait to get the whole data for the whole page, or lazy load from your experience? I'm very new to GraphQL, so
oh, okay.
I don't know much there.
Yeah. So you can also do lazy loading with GraphQL. You can by lazy loading, you mean loading just part of the list and then loading the rest?
Yeah, just load the page gradually, rather than waiting for the whole page to come back.
Yeah, you can definitely join them together. You can say, I just want to load the first 10 items now, then once that is done, I load the next 10. Yeah, so
the benefit is when you want to combine different resources from different services.
Oh yeah, I see. So if you're fetching just from one single API, I guess GraphQL won't really. It can help because it gives type checking, so that is really nice. But it's not like a must-have, I think.
Hi, this is a bit of a back-end-esque question, but how does GraphQL sort of handle caching? Because obviously, if you look at it, it's more of a procedure. GraphQL is just like a transformation layer, so essentially an integration layer. But I'm just wondering, is there sort of any documentation around how it's purportedly supposed to support caching, or does it support cache clearance, or is it just a pure integration layer and that will be handled elsewhere?
So I know in the front end there are several ways of clearing the cache. But I think it does some caching on the back end. I can't really reply to that because I'm not sure. But I think there is, and they give you ways of, if there is, they surely will give you ways of cleaning it up. But yeah, I can't answer that very well. Okay. Yeah, okay.
It seems to give a lot of power to the front end. I'm just wondering how you prevent users using GraphQL. So if they can see the GraphQL endpoint, could they not just send enormous requests and potentially many join requests and setting filters to have very high numbers or something? Do you have to do bounds checking?
Yeah, so all the checks that you do with regular APIs, you will need to do with GraphQL. You can do JWT authentication and all the normal authentication that we do with REST APIs, we can do with GraphQL. We should definitely, because otherwise, yeah. We'll get to you.
So I have a question about scalability. How well does GraphQL endpoint, well, how well do GraphQL endpoints scale on the back end? I've seen this running in Node.js.
Yeah.
I was wondering.
Yeah, so the app that we're building is fairly new, so we didn't actually hit the problem where we have a giant user base. But Apollo has a really good team working behind it, so it should be it should be ready. I think they do performance testing and they do everything. But yeah, it would be a case of trying it out. But the question is that Apollo actually uses just normal GraphQL, and that is being used by large companies, for example, I guess like the Financial Times, and they appear to Facebook, of course, yeah. And it works, and they underneath they use those tools. They use exactly the same tool. So yeah.